Hi, we're going to learn two lessons today. We're going to talk about section 4.5, scatter plots, and then we're going to talk about section 4.6 as well. For section 4.5, we're going to investigate relationships between quantities by using points on a scatter plot. I'm going to show you the three different variations of scatter plots, but first let's do the definition. A scatter plot is a type of graph that plots a set of data on a coordinate grid. And the first one, they're comparing weight and height, and it makes a positive correlation. It reminds me a lot of positive slope because it's going in this direction up. And then likewise, when you look at a negative correlation scatter plot, imagine the line, when we talk about slope, then that's also a negative slope. So know the difference between a positive and a negative correlation. It's also called trends. The last one over here is a shoe size comparison with IQ score. There's no correlation at all. There's no significance about this. In scatter plots, your job will be in the homework to look at different scatter plots and then tell me whether it's positive, negative, or no correlation. They want you also to describe its meaning and situation. The meaning over here, like if you were a child and you're growing in weight, you're probably growing in your height. And so that's the meaning of that one. The meaning of the second one is when you buy the car, when you first buy it, its price will be kind of high, and then it starts to go down as the car ages. And so those are the meanings. And then this last one, if it has no correlation, you're not going to put a meaning to it, so you don't have to do that part on the homework. So in the homework, you're going to have a few of those graphs just to look at and describe if they're positive, negative, or no correlation. So let's get into section 4.6. They're very much related. Regression and medium fit lines, there's a lot of terms they use. My favorite is the best fit line using linear regression. What I'm going to tell you is what they want you to do is to look at scatter plots, pick out 2 points, 2 order pairs, and then write the equation with those 2 points. But I want you to understand that you're looking for the best line. You're looking for a line that will hit as many points on the scatter plot. And then they have these R values. It's a correlation coefficient number that they will put with that. That is something that the computer or a calculator will figure out. We will not do that in our class. It's a big statistics formula. It takes a long time to figure out. But here are what each of these number correlation coefficients look like. And they would love for all of them to be 1 because that means you could really write a line that goes through every point. And so it'd be perfect. And the same for the negative one. That's a great looking scatter plot because all the dots are lined up and you can take a line and go straight through all of those. But that's not reality. Usually it's the good scatter plots are going to be 0.9, so they might be somewhere in between these two graphs. But a 0.8, this looks great. Like you could get a line that could hit almost all of those. And even if they don't hit each data point, as long as those data points are close to the line, then that's going to give it a high correlation value of 0.8. And so that's really good. When you get down to a lower number, like a 0.3 or 0, it's really hard to draw a best fit line to go through those. And so those aren't great. So like if they were doing a biology experiment or some sort of science experiment and they spent millions of dollars in trying to figure out if there's some correlation going on here, and if they came up with a 0.3, they're probably going to just throw away everything because it's not going to help you make a prediction with that data. A 0.8, it will really be a great find. It's something they can use as a prediction model. And so these numbers, the 0.8 and above or the negative 0.8 and below, even though it's negative, don't let that bother you. It's just a negative correlation. That's not a big difference. It's just no big deal. But that's still good. You can use a prediction line. You can do a best fit line through there and predict what something is going to do if you've got that kind of correlation. And so once you get into further science and into college, and if you ever work in a lab and do research, this really means a lot to you. And a lot of the computers and the calculators do all this figuring for you. But it's called the regression line. It's a calculated line such that the distance of all points to the line are at a minimum. And so you're going to be working on a Moby Max assignment that has information about this. And so you've got several problems to go through and work those out for homework.